Today's notes are on 12.7 graphing parabolas in standard and vertex form. So these are all the notes that you are writing down today. What I want to do first and foremost is zoom in a little bit for you to do right about there. And what I would recommend is that you pause the video right now so students can copy down the notes. Now I recommend that you do the same thing so that students can write down the following notes. Please pause the video now. This is the last bit of the notes. Hopefully they have it down. They do not have to write down what is below, of course. As soon as all notes are copied, press the enter button now. Going back to the top, what we're supposed to have learned in our lab on the 12.0 worksheet was there were two types of forms. There's vertex form and there was something called standard form. In vertex form, if you saw something written that was factored with a quantity squared plus a value outside of that quantity, you could figure out what the parabola or the quadratic would look like. And there were certain characteristics about each of those graphs that showed up if you knew what those values were. We played with the sliders in Desmos to figure out what was what. When the A was positive, it opened upward. These all have a positive A value. When the A was negative, the parabola opened downwards. I think of those as sad parabolas. Like that. And I'm sorry, I do whimper a little bit when I think of that, of a sad parabola. Turn your parabola upside down. Okay, with that being said, we go to the three ways you could tell the width of your parabola is dealing with A. I'm going to just put over here, this has to do with your width. Now I have three examples over here just to show you what the A value does. What I'm hoping you realized is that this A value was actually y, let me write that down, y equals 3x squared. This one is y equals x squared. And this one is y equals 1/3 x squared. I changed the A value so that you could see the difference between these three graphs. When you have 3x squared, what it does, because that absolute value is greater than 1, it creates a narrower parabola, meaning a little bit skinnier than a normal width parabola. X squared has an A value of 1. It basically goes through 1, 1. But don't think that it's linear, because it doesn't go through 2, 2. It goes through 2 squared is 4. It's going to go through 2, 4, and negative 2, positive 4. This goes through 1, 3, and negative 1, 3. But it doesn't go through 2, 6. It goes through, if you plug in 2, 2 squared is 4, times 3 goes through 2, 12. So don't think of these as linear graphs, but what it does is you can kind of tell how narrow or how wide a graph is based off of this first unit. It goes to the right 1 and up 1/3, to the left 1 and up 1/3 of the way. I also put on here that these are absolute values, meaning if this was a negative 3, you would have the same width, only pointing downward. I'm hoping that makes sense to you. So let me just kind of if I just copied this one, it's the same width except opening downward. That's the only difference between y equals negative 3x. Okay? Lastly, on this bit right here. HK is the vertex. In the slider of the lab, it was kind of hard to tell because the slider was 1, the vertex was 1. If the slider was a 2, the vertex was 2. But when you see equations, because they're written as x minus h squared, h is the opposite of whatever this value is. Because there's a subtraction sign, we do the opposite. In this form, the k is the same. When you get to math 3, this k sometimes will appear here, sometimes it'll appear next to the y. When it's next to the y, it would be opposite, opposite. I want to say that for the record, just because I do not want to contradict your math 3 teacher. Right now, it's opposite, same. But if the k is on the other side, it would be opposite, opposite. Say that for the record. X equals h is going to be your line of symmetry. If you want to know what that looks like, it looks like a line that goes through the vertex. It goes through the vertex. Every parabola has a line that splits it directly into 2 symmetrical pieces. That's why it's called the line of symmetry. Some people even call it the axis of symmetry. When I say that, some people, I'm talking about depending on who your textbook author is. We use Pearson. Pearson calls it this, but if you were to go to McGraw-Hill, they might call it something else. Okay? But on your homework, you're going to be asked, what's the line of symmetry? And so the line of symmetry is blank. You're going to, it's x equals because it's a vertical line. Notice that there is an x equals for this problem. If you just write down the number, you will not get full credit. It is a line. It is an equation. You've got to have an equation for you to get full credit on that. If you want to find the y-intercept when it's in vertex form, replace x with 0, plug it in, write your answer as an ordered pair. Your domain, on the other hand, is all real numbers because you can replace x with any real number for parabolas that open up or down. But I'm going to say this for your calculus teacher. Sometimes parabolas don't just open up or down. You could have parabolas that open right or left, but those are not functions. Most of math deals with functions, but there are parabolas that go to the left and to the right. They're just not functions, so we don't work with them very often. If this was your parabolas, your domain would not just be all real numbers. You would have to limit your domain like we do with the range. And I say that we're not going to deal with any of them, but that's the future. Okay, that's the future. I don't need to worry about that now. Right now, there's a symbol for all real numbers. If you would like to use the symbol, this is what the symbol is. I do not know where that is on the keyboard, so when I type those up, I think I'm going to type up all reals because I don't know where that is. I'll have to find it. Lastly, the range is always y is greater than or equal to k for parabolas that open up, or y is less than or equal to k for parabolas that open down. We'll talk about that as we do the problem. So what I'm going to do is I'm going to skip past these notes real quick because I'm going to talk about the vertex example. Here is what it looks like. We're going to do 2 examples. Then I'm going to talk about standard form. The first example I have for you is number 2. If you would like to do this as the first problem of your homework, feel free to do so. 1 through 3, give the vertex. This is number 2. This is in the same form. This is either vertex form or it is standard form. So if you know this formula, if you know what is inside next to the x squared, you know the x coordinate of the vertex. If you know what's outside the squared term, you know the y coordinate of the vertex. Without any work, I know what the vertex is. I'm hoping you do. With the person you're sitting next to, discuss what is the vertex and why right now with your partner, please.
The opposite, so negative.
Okay, first period, the discussions are getting smaller. So let me ask this. How many of you know that the vertex is at 0, negative 7? Raise your hand if you got that correct. That is not very many. What I'm looking at in first period is that I saw maybe 30% of my kids raise their hand. So here you go. Think of this like this. Y equals x minus nothing squared minus 7. Is this the same thing as that? Are they equivalent if you take away nothing? Well, that means that h has to be 0. Your x coordinate is taking away nothing from your x squared value. There is no b here. B doesn't exist. So this must mean that this is h and this is k, and I'm going to do the opposite of 0. And by the way, 0 is not positive and it's not negative. So the opposite of, you don't say positive 0 or negative 0. 0 is just 0. Okay? 0, negative 7, opposite, same. That's what that opposite same means. Opposite means change this sign if it's not 0, and keep the same sign as the y coordinate. So let's check for understanding. Since only 30-something% of you got this one right, let's check for this problem, which is number 9. With your partner, discuss with your partner what the vertex of number 9 is. Let's make sure you understand. Discuss, please. Okie dokie. So let's check and see. How many of you said that the vertex was negative 2, 3? Raise your hand. Ooh, that's a lot more. That's over half. I think I got about 60 or 70% this time, which is a good thing. If you said positive 2, positive 3, you were on the right track. You were close. But remember, because our formula says this, I have to do the opposite of whatever that value is. Meaning, if this says positive 2, guess what h is? H is the opposite of that positive 2. The only way to get to a positive 2 is to change its sign. The easiest way is just to go, opposite, negative 2. And then, this stays the same. Opposite, same in this form. Make sense? I'm hoping that fixes some things. Now, you're going to have to answer a variety of questions for number 9. There's a part A, a part B, a part C, a part D, a part E, a part F, and you're going to be doing that for problems 4, 5, 6, 7, 8, 9. There's this many answers for every question, and it goes pretty quick. It's easy. How much work was that? It was 5 seconds of work. No big deal. If I know that's where the vertex is, state the line of symmetry. Earlier, we wrote down what that was. The line of symmetry is x equals the x coordinate of your vertex. You know what your vertex is. You should know what the line of symmetry is. I'm going to even start it for you real quick. I want let's do this out loud in just a second. You're going to say what your answer is out loud. First period is going to be to see if they get more people right than 7th period. Let's see if we can do it that way. The line of symmetry is x equals what? Say it out loud.
-2.
There you go, 7th period. That's what first period thinks. It's -2. Good job. If you are going to get full credit on your test, if I ask this question, don't forget the x equals. Full credit. It's an equation. It's a vertical line. Where are all the x's equal to -2? It's symmetrical about that axis. Okay, so we have part A. We have part B. Give the y-intercept. In our notes, we say to find the y-intercept, we replace x equals 0 and solve for y. And we're going to write it as 0 comma y. So I plug in 0 into this problem. Off to the side, I might do -1/4 times 0 plus 2 squared plus 3. Just going to work it out. Parentheses. 0 plus 2. 2. 2 squared. 4. Multiply before you add. 4 times -4. -1. Plus 3 is 2. We don't just write 2. 2 is the y-intercept. That's where it crosses the y-axis. I want a coordinate. I want a location. Where does it cross the y-axis? At 0, comma 2. Some people will just put 2, but we're going to do it this way. It's more specific, and because we're being more specific, we can always adjust the other way. I'd rather you know the more detailed version than the shorter way. Part D, sketch the parabola. I'm going to go over here and sketch it on this thing. Do you know where your vertex is? -2, 3. I hope you know what quadrant that is in. If I start here, and I'm going to go in quadrant 2. -2. You don't have to be too detailed. I usually just guesstimate. -2 is this way, 3 is that way. There's my vertex. Does the parabola open upwards? Is it happy or is it sad? Is it wide or is it narrow? We're sketching the parabola. And this kind of makes sense because it's supposed to go through 0, 2. I'm pretty close to that in my sketch. I might need to make it a little wider because I think I should have went right about there for 2. The domain. I abbreviate domain. I usually put a D, and I usually put a colon there so I can say what the domain is. The domain is, can I plug in anything I want in for x? Can I plug in a -100 and find a value? Can I plug in 0 and find a value? Can I plug in 1,000,000 and find a number for that? I can plug in any number I want. Therefore, I can plug in any real number and get a real value. My domain is all reals. My range, on the other hand, talks about our y values. Our range, we don't have any values that touch where this parabola is going to have a y value of a 4. It doesn't have any y values at 5 or 6 or 7. But over here at 2, I have a y value. At 2.5, I have a y value. Even if I go down here, there's going to be some place where the y is equal to 0. There's going to be some place where the y is going to equal -100. It could be way off my graph. It could be really, 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 really far. But there are going to be y values used here and below. So how do we write that? Our range is the y's have to be less than. Can it be equal to? Yes. which y coordinate? What number goes here? I'm hoping you said 3. They are the y values that are here and below. You're going to answer A through F for problems 4 through 9. But then, when you get through 11 through 16, the funny part is I put in your notes, you'll see, 11 through 16. Number 10 is missing. Where did it go? I don't know. I know some of you will point that out to me. Mr. Prom, where's number 10? I don't know. It's missing in action. If you find it, let me know. Then we'll do the problem. But since it's not there, bonus for you, okay? Number 15 is intercept form, needs to be converted, okay, blah, blah, blah. But now we have to know how to do standard form. Standard form is when there's a b value, when it's ax squared plus bx plus c. There's 2 ways to really do this. Most math teachers I know will make you memorize this formula, x equals negative b over 2a. It's pretty much the first part of the quadratic formula, something you've already memorized anyways. It's the front. And if you want to find the y coordinate, you can just take it, plug it back in. That way you only have to memorize one formula. Or what we're going to cover in 12 point, I think it's 9, we're going to ask you to complete the square on these things so that you can put it into vertex form. You'll see some examples of that later on. Okay? So let's go ahead and use this formula on the problems down below. Number 11. State the line of symmetry. So the first thing I'm going to do is I'm going to do negative b over 2a. Negative b means the opposite of b. Don't think of it means it's always negative. It means it's the opposite of whatever the b value is. If b is negative 12, you turn it into a positive 12. A is 3. So 2 times 3 is 6. 6 goes into 12 2 times. That was amazing. I didn't even know I could mess up that quickly in the video, but I did. Sorry, 7th period. So I now know what the line of symmetry is, and to give full credit, tell your partner what you're going to write to get full credit, because there's something that I want you to remember. Discuss. I'm hoping you said, don't forget the x equals. This is an equation. Now it says state the vertex. Well, this is not in vertex form, but you now know where the line of symmetry, this cuts it in half. This always goes through the vertex every single time. So if I know that, I actually have found half of my vertex. I have found the x coordinate of your vertex. Now, how do you find the y? Scott has a formula for it. Or you can take this 2 and just plug it in. What I generally do is just do this stuff either on my calculator or in my head. I plug in the 2. Well, what do you get for the y when you get that? So this is 12 minus 24 plus 4. I'm getting negative 12 plus 4 is negative 8. Is that what you guys got?
Yes.
Or are you just trusting me? You guys trust me? That's awesome. The nice thing about standard form, and I wrote this as one of the answers to your homework, give the y-intercept. I know what the y-intercept is. It's very easy. You could do this the same way as you did for the previous problems where you plug in 0 and you plug in 0. Or you can just say the y-intercept is 0, comma 4. It's the c value. That is the y-intercept when it's in standard form. It's kind of nice. There's really no work for it. But if you want to, you can plug in 0 here and 0 there. Then you can find the y-intercept. Write it as an ordered pair. Sketch the parabola. So I'm going to go over here. I'm going to go to 2, counting by 2's, and -8, counting by 8. I know it's down here. Does this parabola open up or down? Is it wide or narrow or normal? This is still the same A value for both. Wide or narrow or normal. You should be able to answer that. Tell your partner what it is.
It's narrow. Because it's greater.
So I'm making a pretty skinny parabola opening upwards. I'm not writing out where it intercepts the x-axis or where the y-intercept is, but the y-intercept goes through something like 4, so that looks like it's going to hit through 4 somewhere. Okay, it's just a sketch. We don't have to be that detailed. Our domain is all reals. Our range, the y values have to be greater than or equal to, what's the k, the y coordinate of your vertex? We have y values bigger than -8, greater than or equal to. There's nothing below there for our y values. I'm hoping that all makes sense to you. We're going to stop your notes right there.